we're going to continue with the API that we started building last time around. And this time, we're going to add full CRUD to the API. So just like if you watch a cooking show, they already have the finished product ready. And we're just going to display what we're going to be doing in this video. So I made a little button here to create a book. So we can insert a book here. I think the next book in the Harry Potter lines is Goblet of Fire, J.K. Rowling, some publisher, and we'll insert an image here for the book, create it. And now we have a new book here, and we can update the book also. So let's say that we want to edit the title here, Harry Potter and the Goblet of Fire, update book. And now it's called this. We can also delete the book. Are you sure you want to delete it? Yes. Let's delete some more stuff here, delete book. And I'll just start off by making a working directory, video 2, go into video 2. And I'm just going to clone the directory from last time because we're building exactly on top of that. So git clone https github.com alex/programming2 video 1. And once you have this, you should be able to see that there is a directory called programming2 video 1, cd programming2 video 1. And here we have all the stuff from last time around. All right, so we're back inside the program here, and let's just start out inside of the API layer in order to create one endpoint for creating a book. So right now, we're going to follow the same procedure as we did with get, except now the endpoint is going to be a different request type. So HTTP, they have request types. Get is by convention used for retrieving data, and by default, the requester will never attach what they call a body to the request. And that's going to be different now that the client is supposed to create a book, because they're supposed to attach a book object in the format of a JSON. So what we can do now is we can write HTTP post and then still have a route here. So the client must still send the request somewhere. Now inside of the method here, we'll just make a void just for demonstration purposes and call this one post. We can, inside of the parameters here, specify an object. And that object is coming from the body, or what we call the payload of the request. Last time I spoke about serialization, so we can serialize and deserialize objects from C# to JSON and also back again. And that's what we're going to be doing now, because when we say we want some kind of an object, we already have a class here called book. Let's say we want a book attached. What we can do is we can create an attribute here and then write from body and then just write book and give it a name like book. And let's just return the same object as the requester sent to us. So right now it's a void. Let's change that to an object for demonstration purposes and just run this one here. And now I'll open up Swagger and I'll demonstrate exactly how this request is different from this request we built last time. Okay, so here it is, the request from last time. We're sending a request. And we can see that there are no parameters we are attaching. We're not making a body or anything like that. We can just press execute and we're sending a GET request. If you're curious as to what you're actually sending here, you can always open up the networks tab here and press the execute here. And then you can see the exact HTTP request here. And this is the response. So we're not really needing to attach any data to a GET request. Sometimes we will add an ID or something into the route. So we might say books/1 if we want book number 1. But we don't really put a body in there. With post requests, on the other hand, we should attach some data. So right here, it's just request body and it's a certain format. You could also have a text-based body or whatever. But generally speaking, we're going to be working with JSON bodies. So for demonstration purposes, let's just send this JSON object here, press execute. We're getting to this point here, localhost port 5000/API/book, and then we are getting this response here. And of course, we're getting this response because the endpoint here simply just returns the book object, and the book object just has a title. So of course, this is not the full model that we have. This is just something that I put here for demonstration purposes last time around. You could also put in an anonymous object here. It doesn't have to be an instance of a certain class or anything like that. But this is the basic difference between making a GET request and making a POST request. So from a technical perspective, the different HTTP methods like HTTP POST and HTTP PUT and HTTP patch and all those, they don't have a whole lot of difference. We mostly use them for convention. So when the client makes a POST request, they signify that they want to create something with a POST. As opposed to if you want to update something, it is convention to write HTTP PUT. So PUT would be what we call an update request. It is also very similar to what we call a patch, but there are so many different HTTP types, and they are not even all supported in this framework here. Mostly we're going to be working with GET, POST, PUT, and delete. So these correspond to our 4 CRUD operations that we're going to be using in this very video here. So I'm just going to go back to having a void here, and I'm going to demonstrate some things that relate to the attribute we have right here. And we're going to talk about how we design APIs now. So APIs, they should always be signifying toward the requester what's going wrong and what they can maybe do differently. And the server should always be trying to validate whatever the client is attaching. So let's say that we try to make a book here. So there is some object here that is a POST book object that can be different from the data model of the book. So in this instance, we're generating the ID inside of the database, which means it's counterintuitive to let the client attach an ID to a book that hasn't been created in the database yet, because how would they know what the ID was? So they only need some certain pieces of data, like the title and the author and the publisher or whatnot, in order to create this book. So of course, our endpoint here should require only the data that is needed for doing this particular action. And this particular action, let's say it requires a title, and we also have some rules for this title. So let's create something here. I'm going to create a class here, public class, create book DTO. And I'm going to call it create book request DTO. And what this model is responsible for is to just take all of the data that we require once a client wants to create a book, and then we will also validate whether or not the data that was provided was what we want to have. So this is what we call server-side validation we're going to do here. So let's just, for simplicity's sake, only require a book title. And I'm going to put in from body here. So I say the requester should supply some object of create book request DTO. And I'm just going to call this one DTO here. And now I'm going to say public string book title. Get set. You should still put a getter and a setter here, because you need getter and a setter for serialization and deserialization. So when it's transforming your object to JSON, or when it's taking a JSON and transforming it to your C# object, it needs the getter and the setter. So even though you're not exclusively using them always, it is being used behind the scenes. And now what we're going to do is we're going to add an attribute, and this is classified as being what we call data annotation. So I'm going to write min length here. So you see, this comes from something called system.componentModel.data annotations. And this data annotations is something that we use for validating data. So I'm going to write a number here because it requires a number. So I'm going to say that the title should have a min length of 5. So there should be at least 5 characters when you try to create a new book in the title of the book. Here I'm just going to return DTO. So just not going to call anything inside of the service or anything. I'm just going to say, I'm just returning the object. So now I'm going to say, try this one out. Let's create a new request here. And the book title is A. We're going to try and click execute here. And we're getting a 400 status code back. Status codes, they always indicate what's wrong with a certain request. In this instance, there is a validation error occurring. And the validation error occurring is because of the annotation that we put into the model. So the one we have right here, create book request data transfer object, that's what DTO stands for, right? It has a min length for this property. So we're getting to this endpoint here and we're doing the parameter binding. So we're taking whatever JSON is provided and we're seeing, okay, there is a book title in the JSON. And then we're looking at the data attribute here. And then we're seeing is the minimum length 5. If not, then a certain response is being created behind the scenes. We don't have to do this manually. This is being done by the ApiController attribute. If we remove this one, we don't get this behavior. So this behavior is both amazing and also annoying. So one of the things that's amazing about this is you just have to specify the rules for your request object. So if you have an object that you must supply when you want to update a book, or if you want to create another type of book, you just create a class for it and then you put the data annotations into your class. And then once you're sending the request, all of these data annotations, they're being evaluated before you're even reaching the endpoint. So this is really cool, but there are some problems with using the ApiController attribute that we're going to get back to. Right here, this is like a massive response just to tell the client that the book title should be length 5 or longer. So there are changes that I would be making here to this kind of response. And this is actually not the only thing that the ApiController attribute is doing for us. I'm going to show you something else. And just before I show you that, I'm going to make this one an allowed book title. So now it is longer than 5. Now we get a 200 status code back. 200 means okay. So that means that there was nothing wrong with the request. You see, if it starts with 400, it means that the requester did something that they shouldn't do. So there is something client side wrong. If it's something 500, it means that there is something wrong server side that is not because of a bad request. So 400, you would typically tell the client to do something else. And 500, you would typically just let the client know that there is something wrong. And anything 200, that is a type of success. There are also 100 or something or 300 or something that we very rarely use. But 200s and 400s and 500s we use all of the time. Anyways, I'm going to show you something else that the ApiController attributes is also responsible for doing. So let's say that you're doing something where you're trying to create a book here. So you're getting past the data validation here. You have a good title here, and you're getting to the service layer. So you're writing a book service, create book, and what I would do here is I would take the DTO and then just put the title in here. So I wouldn't take the data transfer object model and let it move to other places inside of the application. So, you know, the service that's a layer below the API layer, and then the infrastructure is a layer below the service. The transfer objects is just a transfer between the API and the client. So you shouldn't take your data transfer object and put it other places. Just let it stay here in the API layer. You can create a separate file for it if you want to do that. It's not so important right now, but I'm going to just take the book title out of it and just create this method now. And just let's just pretend that it just requires only a string to create a book here. And I'm going to call the parameter something else, title. And now I'm just going to return new and just make an anonymous object here. And I'm going to write title equals title. So this one shouldn't be a void. This one should just be an object. So now we're calling some method in the service. The service is creating a book based on the title and returning it back to the controller. So now we have this book here. We can write var book equals book service.create book. And we just have some object here. And we can inline this. And now we don't have to do it in multiple lines. But let's pretend that we had some operation inside of the service that checks if the book already exists. So if true, this is just demonstration purposes. So this is always going to be equal to true, right? Throw new exception. We could find a very particular type of exception to throw here, but I'm just going to demonstrate this with the basic exception. Book with title already exists. So pretend that we're trying to create a new book and we figure out that there is already a book with that title. We're just going to rerun the program now. And now the program is running and we're sending a new request. And now we're getting this response back. We're getting a 500. So there is something wrong server side. And this is actually super interesting what's going on here, because now the ApiController attribute, the one that we put in the top of the book controller, this one automatically finds out that an exception is being thrown. And once the exception is being thrown, it will terminate the HTTP request and let the client know this is the response body. You see, just previously we created a new book and we got like the book object back. Now this is the response. We just have this massive piece of data right here. And all of this data, this is not always what you want to have as a client. But it's a great service that at least when an exception occurs, the ApiController attribute sees that an exception occurs, it makes this response for us. So again, just to summarize some basic programming, what is an exception? Well, an exception is an exception to the rule that a method should return something deterministically. So the method here, create book, has a job, and that is to return an object to the caller, which means that returning this object to the caller is being interrupted. You see, typically when you throw an exception, you expect the exception to be caught somewhere. So that is very much equal to if we just surround this one with a try-catch block. So let's say we write try catch exception, and we can give this one a name E, and then here we can make our own custom response. So typically when we want to make a response to the client, we would do something like HTTP context, then write a response.status code, and then we can make a custom status code. So in the case that there is being thrown an exception, somewhere down the line, we're catching it here, and then we are saying, okay, we're not actually making a book now. Now we need to think about what's going on here, and then we need to return some object, return something went wrong. So let's say that this is what you're doing right. Saying 314, that's a status code, and then you just print this string out here. And you go in here, and you click execute, of course, we get this something went wrong. And then we're getting this 314 status code. This is a super amazing status code. You should look it up. But this is just us making custom logic to what's going on in the occurrence of an exception. So in many programs, because there are so many things that can go wrong, let's say that the book service exception here is like a validation exception. Validate. Then the controller here would be like, okay, well, first of all, I'm going to catch a validation exception V, and then do something with that and say, okay, hey, buddy, your request was bad because of yada, yada, yada. So all of a sudden you have this massive endpoint here with all kinds of exceptions that you're trying to catch and then signify to the client, oh, it's going wrong because of this, because of that, or whatever. There are cleaner ways we can handle that. And one of the ways we can handle that is just by not catching any exceptions and then letting the API controller say, hey, there was an exception thrown, and then let that one return whatever it wants to the client. And this one will also be responsible for logging. That's why previously, when we weren't catching the exception ourselves, so when we had an unhandled exception, we got this one logged here. So, the developer can go in here and be like, book with title, blah, 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 already exists, and figure out what's going on, right? But generally speaking, the way that I like to do this is don't use an API controller. Now you have two problems, right? The first problem is you have to manually validate the book. And luckily, that isn't very hard. There is a almost built-in way to do it using validators on top of your endpoints. So that's not a big problem. Then you have another problem, and that is, what about exceptions? Now, if you have unhandled exceptions, let's say that we're not actively trying to catch this one, then what do we do now? Like, we need to have some kind of default way of responding to the client. And we can do that with what we call middleware. So middleware, that's functions that are being triggered continuously when you send a request. So we're going to have this middleware that is just trying to process the request like in a completely traditional fashion by reaching this endpoint and going through the request and then seeing if there was an exception thrown. So this is very much equal to, you have the good old meme with trying to take your entire program and then just wrapping it in a try-catch. That is almost what this global exception handling will be doing. So we already have middleware inside of our program. It's just not doing anything with exceptions. You see, this is a middleware function here, the cross-origin resource sharing. It is modifying the HTTP headers, and it is doing that for every single request. So we already have middleware. Now we just need to add some middleware that is looking for exceptions thrown inside of our system and then figuring out what to do with that. Because the problem with the traditional approach, if you remember the extremely long exception we were handling in here, where we got a 500 status code back, is that if you have exceptions being thrown, let's say in infrastructure, that might reveal something about your persistence, like your database setup. Well, the client shouldn't be notified with what's going on with the database. So you can always, inside of your global exception handling, just check if something is a single exception and just not message the exception to the client. So what I'm going to do now is I'm going to build the middleware function that checks for exceptions inside our system. And then I will enable this one inside of our API. And then I will also make a custom data validation. So we'll use the exact same rule as we've already established here with create book request DTO, but we don't want to trigger it with the API controller attribute up here. So I'm going to make those two things, and then I'm going to get back to you, and I'm just going to explain all the code I just wrote. That's because I don't want this video to be several hours long, but I'll explain all of the code that I write just in a moment. And before I get around to making these two things, there's one modification I'd like to make. And I'd like to just talk a little bit about response types, because we just spoke about the request types here. So we want that the request has a certain format, right? But the response format is also super important. And I like to be very consistent with my API design. So what I will do is I will have one model, and this one model will be the same reused model across all of my endpoints. And it's going to be very flexible. So it can contain multiple types of response data, but one thing it will always return is a certain response message to the client. This is like a way of taking APIs and making them more human-friendly. So I'm going to make a class here. You can always move this to another file if you want to. Public class response DTO. And this response DTO is going to have a string here that is called message to client. So public string message to client gets set. And now I'm also going to have the response data as an object. So public object, and I'm going to make it optional by making a little question mark here, response data get set. So endpoint types, you will often see people use something like action result here as a return type. And then when you use the action result, what you should be doing is you should be taking your response data here, and then you're wrapping it inside of something like an OK response. So this OK means respond with 200 status code, and then let this be the body of the response. However, I don't like doing this because you have to remember all of these different status code names, and sometimes they don't use the same convention. So if you create a new book, you would typically respond with 201. So this created method here has a slightly different signature. And I don't like these inconsistencies. So what I do is I just make my own response DTO. And this response DTO, you can just make like a var DTO equals new response DTO. And here, put in the message to the client, successfully created a book. And then you would have a book here, response data, and go for book service dot create book. And then put the title in here based on the DTO. So take DTO dot, how embarrassing, respond. Yeah, we had the two variables with the same name, right? And this one we can just inline right away. So this could be a method. This is a way of also taking your endpoints and keeping them very thin and letting the service do all of the work. So in here, you could take all of your logic, like does the book already exist and yada, 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 and then let that one throw an exception. Because the middleware that I'm going to show you just in a little while is going to be responsible for making sure that the controller doesn't have to wrap this one in a try-catch. So this was just a little bit about response types. I take literally every single one of my endpoints and just give them the response DTO return type here. And then you basically do the same as this one, but just for this one up here. You don't really require any input here. You just say get books read. So of course here you would also be responsible for setting the status code manually, since the DTO here doesn't contain a status code. Sometimes I will make methods for returning the DTO, and then those methods will also take the HTTP context and manually set the status code. So if we want to manually specify the status code, you can just write HTTP context here and then take response and then just write status code, and then just you can either pick the number and just write like it's 201, or you could say status codes dot status 201 created. So this is simply an int, but it's a constant with a certain name, and then they just put the name of the 201 in here, which is created. So let's say that there is something that is not found, you would write status 404 not found. So this is just a slightly more user-friendly way of doing it. If there's ever anything super specific you want to do, you should probably use the HTTP context, because basically everything that we're doing is we're just finding other ways of modifying the HTTP context. So this, for example, is just modifying the response body of the HTTP context. But I would go with an approach like this: status 201 created, and then return this, which just sets the body of the response. Rarely will you have to set anything other than the status code and the body. Sometimes you will manually have to change headers or read from headers. So let's say that the user is trying to authenticate themselves. They might attach something called the token to a specific header, and then you can find that token by saying HTTP context request, and then getting the headers here. And then the headers, there are all kinds of headers like authorization. And this is where you might keep a token that signifies the caller's identity. And this is something you'll learn about in security, but this is just to tell you that the HTTP context always has all of the data that you need for both the response and the requests. All right, so we're back again here, and I just added this middleware here. The file that we're looking at right now is the program.cs, so the startup file. And the startup file is actually where we will add middleware. So you see within these diamond brackets here, I added something called global exception handler. And the method that actually starts to include the middleware is this one here. So the return type here is a task, and a task is a wrapper for an asynchronous operation. Asynchronous programming is a big theme in and of itself, but that we're going to cover. But we don't really need to talk too much about it right now. What you must know is that we're trying to reach an endpoint based on the HTTP context. So if you remember from previously, the HTTP context contains the data about the HTTP request. So we're trying to process this request. So we're reaching some endpoint like this one here. And you see this is being wrapped inside of the try-catch operation. So we're trying to process this request, and we're saying that we might catch an exception here. And if we do catch an exception, we're calling this handle exception async. So here is another asynchronous operation here. The most important thing here is that we're trying to figure out what are we supposed to do once that we are addressing that an exception is occurring. And remember, you should always design programs such that exceptions are exceptional, which means exceptions are not something you want to be thrown. Exceptions is something that represents an unwanted outcome of a method. Let's say that a validation exception or an argument exception, invalid credentials exception, or something is occurring. We are setting the response code of the HTTP response to 400. 400 means bad request. So we're trying to signify if at any point during our operations any of these occur, it is a bad request. There's something wrong with the request. And right here, the exception here, it doesn't just contain the name of the exception or the type of the exception. The exception itself also contains the inner exception and the stack trace and yada, yada, yada. So what we're doing first and foremost, we're taking the logger that is, we're printing to the console that something is going wrong here. So we're logging the exception so that we as developers can go in and take a look at what's actually going wrong here. And then, of course, there is a message. And this message is whatever we're writing when we are throwing the exception. So in the book service here, where we are writing throw new exception with title, yada, 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 already exists. So I just triggered this one. And if we open up the logs now, we can see that we're getting this message right here. So this might also be relevant to return to the client, right? And so not just writing it to the console, but also returning it to the requester. So if you scroll down here, we can see that now we are also setting the response body. Right now, it's just an anonymous object, but I actually think we should probably unify this a little bit by making this a response DTO and capitalize this response DTO and capitalize this just to have more consistency. So what we're doing here is there are some cases where we will not take the message from the exception. You see, the message from the exception was something like this here. So we're writing whatever is going wrong. Sometimes we want to tell the client what's going wrong. We don't want to tell the client what's going wrong if we have an internal server error or not implemented exception. So something like having a networking error or having a database-specific error, it's more reasonable to tell the client that they could not process the request rather than telling the client that there was a foreign key constraint or something like that. But everything regarding client-side errors, so all of these 400 and somethings, these are being addressed by this block here. So we are not returning inside of these blocks, which means that all of these blocks, they will still be impacted down here, where we are writing the actual exception message in the payload. And this is the response that we're getting back. Book with title, blah, 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 already exists. This is a response that the client might actually find useful. So the other thing I was adding was this one here. And I haven't put it into use yet, but I'm just going to do it in a couple of seconds. So we are subclassing something called action builder attribute. And this action builder attribute has knowledge about what's going on inside of our endpoints. So all of our controller methods like this one. There is a request here that contains some data. Now we're trying to figure out whether or not the model is valid. In the alternative outcome, it means there was something wrong. And if there was something wrong, we're going to find all of the errors using this model state, which is on the context. And then we're going to return this to the client. This one is not concerned about exceptions. This one is only concerned about validating the data transfer objects. So we're just looking at, okay, is this here passing or not passing based on these data annotations? Anytime you use data annotations, you can use this one as well. And I'm just going to attach this one to this method here. And we're just going to import this, import missing reference, and then just make square brackets around it. So there is a difference between filters and middleware. Middleware, they will be executing for every single HTTP request, whereas something like a filter here just applies to wherever we assign it to. Sometimes you might have some very, very, very particular data validation. Let's say that you have some custom business logic that does not correspond with any of the validators that you can find inside of this system.component model.data annotations. Like there are many of them. So like if you want to say not null or should do this or that, well, you can probably find it in there. But let's say you have something completely different. Let's say that you find out, well, the publisher should be only one of 3 possible publishers. And you make a custom data annotation for that. That's what I've done here. So I have a class called value is one of, and it is subclassing an abstract class called validation attributes. The only thing you really need to know about this one is that we have a constructor here that takes in an array of strings that are the valid strings, and then we have an error message here. And when we execute this data annotation validation, we're just trying to look if the list of valid strings contains the given string. So let me just show this to you. Let's say we have public string publisher get set. What we're gonna do now is just we're gonna say value is one of, and you can see that I have my custom data annotations namespace here. And here I just start out by making a new string array. Initialize it with, let's say, publisher 1 and publisher 2. So these are the valid values, and let's also specify an error message must be one of ... So you can write, of course, anything you want in this error message here. And let's just rerun the program and test this one. Because there are many ways of validating data inside of APIs, and C# has a bunch of different frameworks and libraries for validating data. Namely, there is one called Fluent Validation that a lot of people like. I think this one is super clean. Like data annotations, you can read this like you're reading English. You know, book title must have a minimum length of 5. Publisher must have a value being one of these. It's very clean. This is still extensible and flexible, so you can do a lot of things with it. Let's make the next one, the update one, HTTP put. And first off, validate model. And now we're going to put the route. It's just going to be /API/books/book ID inside of curly brackets. And now when we make the method here with response DTO return type, we can get the ID here from the route by making an attribute from route type int name book ID. And we also need an object from the body, and that is the data transfer object. From body update book DTO, and just call this one DTO. And let's create a class called update book DTO. Public class update book DTO. I'm not going to add Aleph validators in here or anything like that. I think you understand the concept of data validation on the server. You know, client data should always be validated once you're getting to the API. But just to finish this off, public int book ID get set public string book title get set public string author get set public string publisher get set. And this one I'm gonna capitalize, and public string cover image URL get set. And I'm gonna put just one validator in here just so I can demonstrate something later on. And we will modify the response status code for 201, return new base response DTO, message to client, successfully updated, response data, Something like an update function shouldn't always have response data, because supposedly the client already has the response data, but it depends on how you want to design the API. Does the client actually expect that the updated book is returned even though they have it themselves? Because supposedly they already have the object right here. We're just going to assume that they actually want to have a book being responded back to them. Update book DTO, book title, DTO, book ID, DTO, publisher, DTO, cover image URL, DTO, author. And here I always, when I get to the service layer, I don't want to have any DTOs in there. So I'm going to rename these. Why do I have so many properties, man? And this one should return the book that is updated. And I'll talk a little bit more about models just in a little while. For now, I'll just write book repository, update book, and then we'll put in all of these properties here: book title, book ID, publisher, cover, image URL, author. And we will return this as well. So you see inside of the infrastructure layer here, we have this model here that is a book read query. Notice that the book read query doesn't have all of the properties that the data model does. And that is because I like to make distinctions between query models that I use to get data out of the database and the data models that are the tables. So in many applications, once you start getting into some more complex queries, they never correspond with your data model one-to-one. So I like to build models that are specific for what I'm trying to query, so I don't get like excess data out of the database or have to do in-memory joins or anything ugly like that. So that's why I will make a directory inside of infrastructure and then just call this one query models. And then I'll make one called data models .cs. Why did I make .cs there? And without any file extension, of course. So we could have a book.cs as the data model, and then inside of the query models, we could have the book feed item.cs. So this is concerning exactly the data that we want to return under some circumstances. So this one has fewer properties than the raw book. And also, if you're thinking, why don't you just make separate constructors and making nullable properties and whatnot, you will reach a point where you will have so many different use cases for the same object that the purpose and the responsibility of that model becomes polluted. So I like to keep it somewhat clean, such that this model is being used to query data for some particular feature. And then if I have like a get books by ID, so I have like an info page for one book, that I use another model. And of course, that one model might just correspond with this one one-to-one. I'll just build the book model. We need all these, right? And then we also need the public string publisher get set. So we have a couple different models already. You see, we also have models inside of the API layer. That was the transfer models. So I'm going to make a transfer models. And in here, I will make like a create book request DTO.cs. So this is a particular model that we're going for when we want to create a book. We might have another one for updating books. So all of these different things, they have different purposes, because you see these models here inside of the API layer. We're clearly adding data annotations, but it would be weird to add data annotations to a model that you have inside of your infrastructure layer, because why would you be validating client requests in the infrastructure layer? So I like to keep things at least somewhat separate. Transfer models are transfer models, and query models are query models, and query models don't correspond one-to-one with our data model, although, of course, they will have some names that are corresponding to column names. But that's about it. Update book request DTO.cs. I think these might be our only transfer objects. Take the update book DTO here, put it inside of this one, delete the class here, and import data annotation. Do the same thing with create book request DTO. And then, of course, we will also have our response DTO, response DTO.cs, and it's just going to be this one. So I hope I don't break too much by moving everything around. It's always good to have some refactoring going on, right? And now just import missing references. Yeah, this one you should call a updated book request DTO. And the same thing. And of course, everything else also needs to import that namespace. Isn't programming fun? And this update book, I'll just let it return the book type here. And of course, update book in here. And we're going to continue importing references. And now I think we are at a point in time where we have all types sorted out. And for the service method create book, I will just make it return a book here, and then write return book repository, create book. And we can actually save a little bit of time here with this service method, because we need basically all of the same stuff for creating a book as updating a book, except we don't need the ID here. So thanks a lot, Alex, from 10 minutes ago. Create this method here. And I'll just go ahead and also create the service method for making the deletion here. Click void, delete book. We don't suspect we're gonna need the book in the client side just because we're deleting it. And I'm gonna make int book ID. And because it's a void, we don't need a return statement. We just write book repository, delete book, and then put the book ID inside of here, and then just make this method here. Now we have our 4 methods that we need to fill out here. So basically every other layer is done. I think I'll just adjust this one. So first it wants title, book title, DTO, publisher, DTO, cover, image, URL, DTO, author. And apparently we also need these properties on the create book request DTO, but we have them in here. So I'll just copy these. And there is, of course, a fine line between having models that are very similar and simply duplicating code. So for something like this, the only reason why these models are different is if they have different data annotations, right? So right now they do have different data annotations, and therefore they also have different use cases. And of course, the book update still needs a book ID, but other than that, they are absolutely identical. So we'll let them stay as separate models. And now the only thing we need to do is make all of the queries here. So we'll update a book here. So first of all, we'll make the SQL string here. So var SQL equals, and then I will make a little $ here. And then I'll also make the @ sign. With the @ sign, we can go a line down and not have to concatenate the string with itself. So that's nice. And then we'll need to use this SQL expression here using var con for connection, data source, open connection. Take the SQL string here and put it inside of the query method. Con query SQL, and also put the parameters in. So we haven't written the SQL statement yet, but we expect to get a book back here. So I'll write query first. If you only query and you don't query first, you will get an IEnumerable of book and not a book. So that's obviously not what we want. Parameterize all of your inputs here. So you're going to take the book title and book ID, the publisher, and the cover image URL, yada, yada, yada. And we want to make sure that we don't get a SQL injection attack. And we do that by parameterizing all these values. So you could write book title equals, and then the parameter book title. The shorthand version of this is just listing the inputs like this: book title, book ID, publisher, cover image URL, author. I think that's it. So update book, update library app.books set book title equals to book title. So the way that we reference the parameterized values is using this little @ sign here. Publisher equals @publisher, cover image URL equals cover image URL, and then the author equals @author. And of course, if it's an update, you should always add a where clause. So update the books where book ID is equals to the book ID parameter. And here I'm actually gonna return things in the same fashion as I did up here. So I'm gonna do like this, because an insert can still return the impacted row. And I like to use this because when I update a book and the client might actually request the book, instead of writing a new request in order to find the book by ID, we can just write returning and then just put in all of these. And you still need a publisher here as interpolate name of book feed query and then publisher. And this is just to get a little bit of type safety. And of course, we're not going to reference the book feed query. We're going to reference book, because this is a different model that we're using. The book feed query didn't have a publisher on there. And make a semicolon, end of statement, and that's it. So the create book is almost identical, and then delete book is slightly different. And I'm going to show you how I'm going to handle this delete book here. I'm actually going to return a Boolean, and now I'm going to write the SQL here. And we don't need to interpolate anything in here. I'm going to write delete from library app. But books where book ID equals book ID. And what I'm going to do now is still open a connection the regular old-fashioned way using var con equals data source open connection. And now instead of using the query method, what we're going to do is we're going to use fun.execute. Execute returns the number of impacted rows, which means if you successfully delete one row from a table, it means you have one impacted row. So I'm going to execute the SQL with the parameters, and that is just an anonymous object with the book ID. And what I'm going to write now is equals 1. So this is a test for equality, and we're going to return the test for equality. So what I'm saying here is it true that the amount of rows impacted on the execution is 1? And of course, we just return that. And then we have a delete book method here. I'm going to fill out the create book method on my own. I don't need you to see that because it's basically just this query with a couple different keywords. And then inside the service here, there is actually something I want to demonstrate here. So you could take this delete book query here. You can say var result equals the book repository dot delete book. And here we can say if not result, and we can just throw a new exception. Exception could not insert book. And we don't have to try and catch this exception in the controller that calls this one, because our global exception handler catches this one. So if we want to do things like figure out if a query succeeded or anything like that, we can just do it in here in the service. All right, so I just filled out this infrastructure method here, which simply just counts the amount of books that has a certain title and then executes whether or not that is 1. So for this one, we can have a really easy control flow inside of our service layer, because we can call repository methods and just throw exceptions once there is something unwanted going on. So a lot of the preparation we made before we started building the features with the exception handling and the data validation stuff, that is actually what's allowing such an easy control flow like this. And also that's what's allowing the controller methods to be relatively lean without all of those catch this exception, catch that exception, catch all kinds of exceptions in each single block. So it's a time investment to make up front that's going to pay off now. And I just need the delete one real quick, but it's not going to take a lot of time to do that one. HTTP delete, validate. We don't have to validate the model because there's no DTO for the delete method here. So we can just say routes, API, books, and then book ID within curly brackets here. So make a public response DTO, delete, and then you can say from route, book ID, which is an int, and make the scope of the method. So this is probably the smallest one. Okay, maybe the get one is even smaller. Return a new response DTO, and then put in the message to the client here. Message to the client, successfully deleted. And let's just make sure to call the book service delete book, and this one is a void. So we don't even have to take the response data and put it into the response DTO here. So this one was the easiest of them all. Okay, so we have the application up here, and we can just try and create a new book here. And I want to trigger one of these validators that we built previously. So we have a validator here on create book request DTO that takes a length 5 at minimum. And if we trigger this one, we get a response here back from the server. And let's also try deleting a book here. So yeah, the application works just like I showed in the beginning of the video. I'll leave all of the code in a Git repository. So the Git repository for video 2 will be separate from video 1. In the next video, we're gonna start talking about how we can test the API. So right now, our testing has been limited to just clicking a button and seeing if it does what we think it does, and going into Swagger and inputting some data. But of course, we need much better tools in order to test APIs. So stay tuned for next video where we're gonna test the API we created right here.